Okay, Unit 6, Day 8. The objective is to show that the sine of an angle is equal to the cosine of the angle's complement. Express the sine ratio in terms of a cosine and vice versa, which are called cofunctions. So a few people have asked in class, they noticed when we were doing Day 7, they noticed that sometimes the fraction was the same for two different answers, and they were kind of approaching this subject. So let's get into this. Solve using any of the trig functions. So here we are. Here's our angle up here. As we were referring to, there's Grover. So Grover is up here, and he's looking, and we always knock this one out of the way. There's a hypotenuse. We don't have a number there, so we're not going to be doing hypotenuse. If we don't have hypotenuse, that means it cannot be a sine or a cosine. So we know we're going to be doing tangent. So Grover looks and says, the 6 is over there, way over there, which makes it opposite. And the 3 is right here, right next to him, adjacent. So we're going to be doing tangent. So that's going to be tangent of the angle is equal to TOA, opposite over adjacent. Okay? So we don't know the angle, so we're going to do inverse tangent of 6 divided by 3. Now, you can type in 6 divided by 3, or you just type in 2, because it's the same thing. And you're going to get 63.4. So actually, we've been rounding to the whole number, really close to 63.5. We're going to go with 63 degrees, estimated. Okay? Now, we look at this one over here. Grover's down here. Here's our hypotenuse. Once we have a hypotenuse that we're using in the equation, then we know that we're not going to be doing tangent. And we look all the way over here, well, over there, which is opposite. So opposite and hypotenuse is sine. This time I do know 21 degrees equals opposite over hypotenuse. So remember, technically on this one, you want to multiply both sides by x, and then divide by the sine of 21. Or the shortcut is switch them. The x goes to the outside, and the 18 stays on top, and sine of 21 goes into the denominator spot. And now I just type in my calculator, 18 divided by sine of 21. And remember, I do not use inverse, because I do know the angle. And I get 50.227. So 50.2. So the hypotenuse is 50.2. And we do round the nearest tenth there. So whole numbers for angles and nearest tenth for sides. Okay? Another review. Here's Grover. No hypotenuse. So it's got to be tangent. We know that right away. And we know the degrees. Tangent of 56 equals opposite over there over adjacent, right here. So tangent is opposite over adjacent. Well, in this case, trying to get x by itself, we're going to multiply both sides by 18. So we just type in our calculator, 18 times tangent of 56. So that means this side is, the opposite side is 26.68, 26.7. And here we go again. We have a hypotenuse, so it's not going to be tangent. Here's Grover right here. We have the hypotenuse, and right here is our adjacent side. So adjacent and hypotenuse is cosine. We know the degree measurement. Adjacent over hypotenuse. Well, again, if x is on the bottom, we switch places. X equals 21 divided by the cosine of 11. type it in. .4. So the hypotenuse is just slightly bigger than the adjacent side. Okay, so now we're going to work this problem. This problem is actually missing some information. So if you would please write in a 4 radical 2 right here. Now you're going to try to find the missing stars. Well, this is 4 radical 2 right here, because it's an isosceles triangle. Up here on the right side, we have 30, 60, 90. This is our small leg. This is our large leg. This is our hypotenuse. We know the hypotenuse is 10. We're going to go from the 10 back to the small. Remember, we always want to go to the small. So from the hypotenuse is small, we're going to divide by 2. So that makes this 5. And then going from the small to large, we multiply times radical 3. Remember, 3 different sides of the scaling triangle? So that makes this star right here 5 radical 3. And this is 5 right here. Now, there's not a star for that 5, but we are going to need it. We need to find out the measurement of this entire side so that we can find this, and then we're going to use that number and this number to find this number with the Pythagorean theorem. Okay? So, to find this piece right here, this is a 45, 45, 90. These legs. To go from a 45, 45, 90 from the leg to the hypotenuse, we multiply the leg times radical 2. So that's going to be 4 times 2, which is 8. So if the entire measurement here is 8, and this is 5, that makes this 3. So now, we can use that information to find our last star. 3 squared plus 5 radical 3 in parentheses squared equals c squared. That's our final star. So 3 squared is 9. 5 squared is 25. Radical 3 squared is 3. So that's 9 plus 75 equals c squared. C squared is equal to 84. 75 plus 9. We take the square root of both sides, and C, our final star, is equal to 9.2. So our 3 stars are 4 radical 2, 5 radical 3, and 9.2. Hit pause if you need to get anything more. Okay, now some vocabulary. This is in the introduction of the lesson. The sine of an angle is equal to the cosine of the complement of the angle. Okay? And remember, complement, go back to earlier. Complement adds up to 90, supplement adds up to 180. Way to remember this is C comes before S in the alphabet. 90 comes before 180 in counting. So complement adds up to 90. So if we look at this drawing here, okay, we have alpha and beta. A and the B on the inside. So the sine of alpha is equal to, sine is opposite over hypotenuse. A over C. This is horribly drawn. A over C. Still looks like a 9. Tough time today. A over C. Cosine of beta, remember cosine is adjacent over hypotenuse. So adjacent for here is right here. Hypotenuse hypotenuse is there. So that's, again, A over C. The cosine of alpha, again, is adjacent over hypotenuse. And the sine of beta, again, opposite over hypotenuse, B over C. Now remember, if we have 90 degrees right here, then that means alpha and beta add up to 90 because of 180 in a triangle, which means alpha and beta are complementary. So there's a few things we can write here. They're complementary. And the sine of alpha is equal to the cosine of beta. Which makes sense. But here's the sine of alpha, which is the same thing as the cosine of beta. Okay? So they're complementary, and one sine is equal to the other one's cosine. Okay, fill in the blank. Sine of 30. Okay? Remember what it says. The sine of an angle is equal to the cosine of the complement of that angle. So 90 minus 30 is 60. The cosine of 47 is equal to the sine of 90 minus 47, 43. Sine of 66 is equal to cosine of 90 minus 66, which is 24. A little trickier here. Cosine of 3x is equal to the sine of 90 minus 3x. So whatever 3x is, subtract that from 90, and there is